Let's discuss about compute and storage, the two fundamental components of any data platform infrastructure. Let me select the pen. Yeah. So in this lecture, we'll talk about compute and storage. Now, these two are the most fundamental components of any data platform infrastructure. And if you see the modern data platforms, you would have realized that there is a lot of focus on keeping these two as separate. So you want to have these two as are decoupled as far as possible. You don't want them to be tightly coupled. So what I mean by that is, if you look at the older architectures or the traditional warehouses, databases, right? Let's say this is your older database system. You had the compute plus storage, which was tightly coupled. So whenever you loaded any data into this, okay, and you want to query that, let's say you want to query the data which is present in this, you'll have to use its own compute engine, okay, because these were all tightly coupled. Most of the data warehouses appliances like Exadata, Teradata, Netezza, right? They followed the same kind of an architecture when compute and storage are tightly coupled. Same was the case with Hadoop, right? If you remember the good old Hadoop days, we had the let's say the master node, and then we had the data nodes, right? If you remember now about the data node, let's say we have three data nodes, okay, dn1, dn2, and dn3. Now, what this data node consists of? So, if any Hadoop admins are here, right, they would remember these were nothing but servers, right, or machines. It consisted of compute, memory, and storage. Storage was like you would had a multiple hard disk here. Let's say multiple slots where you can have hard disks, right? Which were like, let's say 12 slots, 1 TB each, so you would get 12 TB. And there was compute like 16 V cores and all, some memory, 128 MB, right? Now, because the compute, storage, memory were all tightly decoupled, you were not able to independently scale them. Now, what I mean by that, let's say you have 12 TB and let's say 11 TB is almost utilized. Now, if you want to add 2 TB additional to this, so you could not do that because the maximum size of this was 12 TB. So for that, you had to purchase another data node, right? Another data node. Now, when you purchase another data node, you could not just purchase the hard disk of 10 TB, 12 TB. It came along with the compute and memory. So unnecessarily, you are spending money on compute and memory. Same was the case for compute also. Let's say you want more vcores, you want 32 vcores. Now the problem is, again, you had to purchase a data node which came with storage also. So with tightly coupled storage and compute, you cannot do an independent scaling. Okay, that's what the number one issue. So first is independent scaling of compute and storage is not possible. Second is you don't get the freedom to choose any compute engine that you want. Freedom to choose the compute engine that you want. So here, uh, if you were into the older databases, right, you had to use the same compute engine provided that particular database or by that warehouse. You cannot choose anything else. Now the modern data platforms, right, that is where things like the lake house architecture is becoming so popular. Here storage and compute are different. Okay, so you can have storage in something like your S3 or ADLS. Okay, this acts as a storage, and you can have a separate compute. Now that compute can be anything, right? Let's say if you are into AWS world, it can be an Athena, it can be EMR, it can be Glue. If you are into ADLS, if you are just using Synapse also, right, it has multiple different engines. You can use Synapse serverless SQL or Synapse Spark pools also, right? So what happens is, because you have a separate storage, ADLS or S3, now these are cloud object storages. This is indefinitely scalable. You are not going to face any limits on them. So you get that flexibility to independently scale. Plus, you get the choice to use any other compute engine that you want. Now, in most of the data platforms, right, there are data engineers, analysts, data scientists, business analysts working on these, right? So, and they all prefer different compute engine. Like data engineers would love to have something like Spark, right, because they love coding in Spark. Data analysts, business users, they would like something like SQL. So let's say you are into the AWS ecosystem, you have your storage in S3, so you can provision EMR or Glue for the data engineers, and you can have Athena SQL, right, which is based on Presto Trino. They can use this SQL to query the data, same data which is on S3. So the let's say a particular file is stored on S3 with the metadata in Glue data catalog. The same can be queried using Spark from EMR and using Athena SQL also. So that's the advantage that you get from separating your compute and storage. So this is one of the most basic principle that most of the modern data platforms have been following, separating the compute and storage for mainly for two reasons. One, you get independent scaling of both, independent scaling of compute, independent scaling of storage, plus the most important is you get the freedom to choose your compute engines. And this is where the whole open lakehouse architecture, open data platforms are coming into picture, right, with all the open table formats and all, which we'll talk about in our subsequent sessions. Thank you.